Alright, here we go. 12.2 Arithmetic Series Day 4. So this is our fourth day working on 12.2. First 3 days we were working on arithmetic sequences, and now on day 4 we're working on an arithmetic series. So if you recall from earlier this chapter, a series is what you get when you add the terms of a sequence together. So remember, an arithmetic sequence is one that has a common difference, like an adding or a subtracting pattern. And now we're going to do an arithmetic series where we take those terms of an arithmetic sequence and add them all together. There's a symbol for this, capital S sub n. That capital S sub n represents the sum of the first n terms. So there might be lots and lots of terms in a sequence, but maybe you only want to add up the first 5 of them. Then S sub 5 would be the sum of those first 5 terms. And in fact, there is a formula we use to do this. So that's S sub n equals n times, and then you can see in parentheses, A sub 1, the first term, plus A sub n, the nth term, whatever that last one is that you're interested in, and then all of that gets divided by 2. Then there's a times by n in front of that. Now, ultimately, to do your problems today, you're basically just going to use this formula, and you can put the numbers you need in the places they belong, evaluate, and get your answer. But like a lot of times in our class, I'm always interested in why things work the way they do. So for our first example, I wanted to explore a bit about why this formula looks the way it does and why it works the way it does. So for that first example, we're going to look at a sequence that's already written out as the numbers of the sequence, 2, 8, 14, 20, 26, 32. I can see that it is an arithmetic sequence. I notice a common difference of 6. It's going up by 6 every time. I see there are 6 terms listed, 1, 2, 3, 4, 5, 6 of them. Now, of course, when I see those 6 terms the way they are, if I really just wanted to find the sum of them, it would be easy enough to just press 2 plus 8 plus 14. You could do that on a calculator. Literally just add those numbers together, you'll get your answer. Not all of our series are going to be that simple, though. We'll see the later example we work on, and what is more like the work you do in your assignment today is shown to you as a series symbol, the sum of. Might be more than 6 terms. This one goes up to 12 terms. Of course, that could be even higher than that. And it might be given to you as an expression rather than actually as a list of numbers. So again, for this first example, it would be easy enough to just add them all together. But we know later that won't always be a good idea. So let's talk about this formula and why it works the way it does. What I notice is if I take the first term and the nth term, in this case the 6th term, and I look at adding them together, since that's what the formula asks me to do, well, I notice that 2 and 32 makes a sum of 34. Now, the divide by 2, when you add two things together and divide by 2, what you're really finding is their average. So if I have 2 and 32, and that's a sum of 34, when I divide by 2 and I get 17, it means their average is 17. So you could have had like a 17 and a 17 there, and it would still have made a sum of 34. Now what you might notice is if you take the second term and the second to last term and put those together, 8 and 26 also makes 34. So everything I just said there about dividing by 2 and it being an average of 17, that's true again. And in fact, the middle terms, the 14 and the 20, well, they make 34 as well. So what we find here is that while the sequence itself doesn't even have the number 17, every term here is represented by an average of 17. That I could make this 34 instead of 2 and 32. I could do 17 and 17. And this could be 17 and 17. And this could be 17 and 17. So now I'll go back to that formula, and you can see that when you add the first and last terms, divide by 2, find their average, that would be 17. It means all of these terms have an average of 17, and there are 1, 2, 3, 4, 5, 6 of them. 6 times 17 is how we're going to get our answer here. So let's go ahead and do that. First time using this formula, I'm going to put S sub 6 now. I'm not just looking at an nth term, but rather the sum of the first 6 terms. And it equals, there are going to be 6 sets of, and when I add the first and last, that's 2 plus 32, and all of it gets divided by 2. Well, again, that's where 2 plus 32 makes 34. 34 divided by 2 is 17. And there were 6 terms that had an average of 17. 6 times 17 is 102. So sum of these first six terms is 102. Again, you could have just added them together, but as we'll see in our next example, this formula is going to be really helpful. So let's go ahead and take a look at a problem now that is more similar to the work you're actually going to do for your practice problems today. And that's given a sum from the first term to the 12th term, and then there's an expression here. So first thing I want to think about, you might not need to do this when you get your examples later, but is what sequence is this really even talking about? How do I even know it's actually arithmetic? So I just want to think for a moment, like the first term, that would be 7 times 1 is 7, plus 2 is 9. And if I kept going up, that's a comma there. The second term, 7 times 2 is 14, plus 2 is 16. If I do this again, the third term, 7 times 3 is 21, plus 2 is 23. Now, I'm not going to keep doing this up to the 12th term. That's the whole point of using our formula from earlier. But what I do see now is where this sequence is heading. I see that, sure enough, it's a common difference of 7, so we can now kind of lock in on the idea that what looks like the slope here, that 7n, that represents the common difference going up by 7 every time. And, well, now I think we're ready to go ahead and try to use this formula. So what I notice about the formula is I need to know how many terms am I interested in. I'm interested in 12 terms, so I've got the number 12 going. And to then evaluate this part, I'm going to need to know what is the first term and what is my last term, my 12th term. So I'm going to go off to the side over here and work on each of those. Now, technically, I already did the first term when I was interested in the sequence itself. So here's that first term. It's 2 plus 7 times 1. 7 times 1 is 7, plus 2 more is 9. Now, I also know I'm going to need the nth term, or in this case, it's the 12th term, a sub 12. And that's 2 plus 7 times 12. And if 7 times 12 is 84, plus 2 more is 86. So here I've got my first term and my 12th term, and I'm ready to plug all the numbers into this formula. So now I can go s sub 12, the sum of the first 12 terms, is equal to 12 times, and then I'm taking the average of the first and last term. So first term 9 plus 86, and all of that gets divided by 2. From here, you could type it all in on a calculator at once. Be careful about your grouping symbols and that kind of stuff. Sometimes it's easier to work on it a little piece at a time at first, just so you don't type something wrong on the calculator. So I'm going to do s sub 12 equals 12 times, well, 9 plus 86 is 95. And then that means it's 12 times 95 divided by 2 is 47.5. And 12 times 47.5 is 570. So here I have the sum of the first 12 terms is 570. Now, had you gone up here and kept doing 9, 16, 23, the next one would be 30, then 37, then 44. If you listed out 12 of those, if you added them all together, you should, of course, come up with 570 as well. But I recommend using the formula, and especially now that we know a little bit about why the formula works the way it does, should be pretty useful. So you can go ahead and work on just a few examples today. They're on page 807, numbers 41, 43, and 45. Thank you all very much.